All right, Unit 11 today. Unit 11 going to be on exponents. So we're going to cover an entire unit here. Again, remember 2.5, 3 weeks, somewhere in there to get through all of it. But this should be a little bit easier of a lesson for you, even though most of you knocked out the last one out of the park, all right, with the test we took yesterday. Yeah. Did very well on it. But multiplication world. I will let you read the summary on the left side there at your wish. Don't have to do it now. We're going to hop right into question 1. Okay, growth by addition. It says for every hour you work, you earn $8. Right, Landon, you get $8 at McDonald's. Yep. 1 hour you get 8, 2 you get 16. Can you help me fill out the rest of the chart?
Yeah.
Okay, go ahead.
24, 32,
40, 48, 56, 64, 72, and 80.
That was very disrespectful.
I do have to agree, because he called on Kira.
Thanks, Kira. Well done.
Thank you. Welcome.
All right, so that's growth by addition. Grows the same amount each time. Number 2 is going to show us growth by multiplication. So instead of adding, we're going to multiply. It says you invite 3 friends to a social networking site, and every friend invites 3 friends of their own. Fill in the table. Okay, so you start off with just you. You invite 3 friends. That's a total of 3. And now those 3 all invite 3 friends. And that's a total of 9. So now if all those people invite 3 friends, we will diagram that out. So every n dot is getting 3 off of it.
I could go on forever. Literally forever.
How many outside dots do we have?
Too many.
Count them.
9.
Nope.
Not what he means, Maddie.
Oh, the.
Okay.
Whoa.
Nope. Count the outside dots.
26?
27.
27.
I missed something.
Now, you could do it again. And again. And again.
That's what I'm saying.
Right? So we went from 1 to 3 to 9 to 27. It's growing a lot faster than this one did. Do you see a pattern?
3 times 3 is 9. 9 times 9 is 27.
No, it's not.
Not even close. It's 81.
9 times 3 is 81. So if you were to do it again, and I'm not going to have you draw it, but I will show you what it looks like.
Holy.
That's a lot.
It's 81. Okay, that's what we call exponential growth. It is multiplied together. Each time it's going to grow by a factor of 3 because every person invites 3 more. So what's 81 times 3?
243.
Times 3.
Like
2, 4, 6.
How do you?
Times 3.
249.
Times 3.
Yes.
If you don't know, guys, multiply it out.
That's a lot.
3 times 3.
9,
4 times 3.
12,
3 times 2 plus 1.
4, 7,
Steven.
7.
All right, so we had 27 dots on our drawing. The next one would have 81. The next one would have 243. The next one would have 729. Okay, exponential growth, not just adding like we did in the first chart. Landa, we actually talked about folding of
Why is
paper
it blue?
the other day.
Oh, scared me.
Oh, yeah, that was just yesterday.
How many folds you can do. But we're going to go on to number 3.
I got to 6. Record right there.
Landon's going to read the directions for us
Like usual.
because he's always talking.
It's me, I'm always talking.
Growth by addition and growth by multiplication look different. Match each story with the appropriate group.
Graph.
All right, so growth by addition. If we were to graph this first chart that we did, it's a nice steady, you're gonna get paid $8 an hour for how many hours you work. Call that a linear relationship, it forms a line. Is this one a nice steady growth?
Yes.
It's not.
I mean, it goes
No,
up,
this
side,
one would look like
side.
this, exponential growth. It's gonna get up in a hurry.
To see
And it
what-
went from 27 to 729 in a hurry.
I'd rather have that.
Big difference. So this is the type of thing you want to do when you're investing money.
Yeah.
You want the money you invest to go way up.
Stock market.
Okay? I mean, you could do this and steadily make money. But if you really want to make money, you got to take chances with your investments. Now, you got a good chance to lose them as well,
We got good chance.
but a chance to have your money get up in a hurry. So let's look at this. Question A. The line to buy a movie ticket starts with 5 people and 3 more people join every minute. Does that sound like something that would be steady? Or is the number of people going to get up there in a hurry?
Steady.
Steady. So this is I. Graph I represents that. Question B. Only 10 people saw the movie when it opened, but each day twice as many people show up as the time before.
That's 2.
That is 2. Okay, the number of people is going to get up in a hurry. In problem 3, which graph shows growth by addition?
I like
1. Nice and steady. So this one is growth by multiplication. Next page. I would like you to try 5, 6, or just 5, those A, B, and C there. Based on that information, is it growth by addition or multiplication? And then see if you could draw what the graph would look like. So is it steady going up or is it increasing in a hurry? That's what you have to ask yourself. A, B, and C. Try those 3, please.
Okay, got it.
All right, what do you think on the first one?
Multiplication.
Okay. What do you think?
Addition.
Landon, we got 1 vote of each.
Addition.
Devin? It is addition. You're hiring the same amount of people every year. 250, 250, 250, 250, 250.
Got it right.
B. Kira, I'll let you go first on this one.
Multiplication.
Why?
Because it doubles.
It doubles. It's not adding. Times 2, times 2, times 2, times 2. Gonna get up there and hurry.
See if I get one right.
Well, hopefully everybody's thinking that. Landon, third one.
Addition.
Addition.
Got it all right.
$20 a day, getting paid the same amount each day. Perfect. All right, question 6. Fill out the pattern in each table, describe the growth. Okay, describe the growth. Is it steady?
It's going up by 2. So
And it's got to be true for all of them. So am I adding or am I multiplying?
Adding.
So we're looking at these numbers right here.
you're multiplying.
I don't even know. I just guessed. I'm gonna say adding.
Then you got to tell me what I'm adding each time.
Adding 9.
Adding 9.
Let's go.
Maddie, I heard you say double. That only works for the first one. Because 18 doubled is not 27. Okay, so we are adding addition of 9. Need to do one more, or can you try the other 3?
You can do it in 3.
Okay, go ahead. Give her a shot.
What happened?
It's their lunch period, so
Oh,
I'm going back to their 6th hour.
Bummer. I mean, I'm glad you're here.
so adding or multiplying and say by what?
He's got me stumped.
Which one's got you?
Say D.
Yes. The way I look at it, by adding or multiplying, 4 doesn't equal to 20.
Well, if it's adding, it'd be plus 16.
These are really easy.
If it's multiplying, it'd be times 5.
Addition 16.
Got them all? Yeah.
So where's the 16 come from?
Yeah, where'd you get 16?
She's saying 14 plus 16 is how you get 20. Or 4 plus 16.
Which 16?
How do you get from 4 to 20?
Plus 16.
That's what she got. That's what she said plus 16 for. All right, Devin, you got B?
Yes.
What is it?
Multiply by 2.
Yeah, times 2, times 2, times 2, times 2, times 2. Multiplication by 2. Kira, C. So if you look at it, you got 2 options. Times 2 or add 6.
Here, how old am I gonna be this year?
Times 2 or add 6, Kira.
6.
Okay. What's 12 plus 6?
12 plus 6 is 18. 20. What?
So it's not add 6.
No. So times.
Times 2. 6 times 2. 12 times 2. 24 times 2. 48 times 2. Maddie, I heard you mention D. So your options again are adding or multiplying. So you're either adding 16 each time or you're times 5, times 5, times 5, times 5.
Multiply, addition 16.
Adding by 16. That is correct. All right, Landon, I'm going to give you a shot for number 7.
Oh no.
Why does it make sense that growth by addition results in a straight line?
Because you just keep on adding the numbers up. It goes smoother. So when you add them like 2, you just add another 2 to that, it makes 4, and it just keeps on going even numbers.
Yeah, it's a constant rate of change. For example, if you would graph your hourly wage, you get $8 an hour no matter how many hours you work. And once you get into overtime and get time and a half, that's a different story. Okay, but it is a constant rate of change or constant slope. It is steady. Can use Landon's word there. Okay, on the flip side of that, why is multiplication curved then?
Because you're getting
Cause
the
you just keep
same
on
amount,
times the
just multiply faster.
Yeah, I mean, look at that handshake one that we did at the beginning, or whatever we did, when they invited 3 people, and then all those people invited 3 people, and then all those people invited 3 people. Gets to be quite a bit in a hurry, right?
Yep.
Instead of adding the same number, you are multiplying each time. So it might sound the same that it's times 2, times 2, times 2, times 2, but those numbers get a lot bigger than adding the same amount each time. And again, we've had a couple examples of that. Last one when talking about the mice. Okay, question number 9. Even though both of these tables use multiplication, one table shows addition, while the other shows growth by multiplication. Which table shows growth by addition? A. Why?
Because you're just adding 2 every time.
Yeah, look at the last numbers. Slow and steady. Add 2, add 2, add 2, add 2. If you look at table B, you go from 2 to 4, and then to 8, and then to 16, then to 32, then to 64. We're already at 128. Explain why multiplication is being used to show growth by addition.
because it's going up like right away. It's like going zoom.
It's going zoom.
I always had sound effects.
Yeah, going zoom. Doubling something, just like we talked about, it's going to be a lot more aggressive than just adding 2, adding 2, adding 2.
And going zoom.
Yeah. And you'll notice 4 times 2 is not the same as 2 multiplied 4 times. That's a common mistake. 4 times 2 is not the same as 2 times 2 4 times. Shows you that as well. All right, the final thing we're going to do is a little matching here. Kira, would you read the directions?
Match each scenario with the most appropriate graph. Xylo is learning how to fly a spaceship and does whatever his flight instructor says to do on their flights. In each scenario, the instructor is speaking to Xylo.
Okay, so you're driving a spaceship. The bottom is time, how long we're in the air, and going up and down is how far we're away from the planet. So let's pick one of those. Devin, A through F, which one do you want to do?
A.
Let's do A. So Xylo takes off, and see if you can follow this on the graph. One of these graphs is going to match it. Takes off pretty slow, and then sped up to warp speed 9. Kept saying faster, 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 faster. Which graph
G3.
represents that? Starts off pretty slow and then picks up speed until you're at warp speed.
G3.
G3 is correct.
Why G3?
Slower, then picks up speed, going super fast at the end.
G6.
Yeah, then it looks like we slow down though for a little bit. Take a little break. Does not say that. Lando, when you throw that in the garbage, you are distracted by string.
It's like just.
That is why G6 doesn't work, and you weren't even listening to that explanation. All right, try the other 5. G3 is out. See if you can find the other 5. Please don't comment on which ones you have. I want you to try it on your own based on those situations. If one confuses you, go on to the next one.
Well, I got. Oh, wait, S.
All 5?
Oh no.
Looks like you do. Just not too
Yeah.
confident on them?
No.
Can we use one more
Nope,
than
they all get used once.
It was pretty easy.
I just get confused on B and F.
All right, see how we did.
Oh no.
Madison, pick one that you're pretty confident on.
B,
B.
G6.
Slow down and hover for a minute. So I mean, it's going to be pretty flat for a while because we're not going away from the planet, but time is still continuing. And then they take off again. I agree, G6. Kira,
Yeah.
pick one that you are confident on.
C.
C, nice and steady. Let's fly all the way from your planet to the moon at a nice steady speed.
G1.
G1, nice and steady, slow and steady. Same pace the entire time.
I'm scared.
Devin, you got one of the last 3?
G, G2.
All right, let's go. Whoa, it's too fast. So they start off going pretty fast and then start to slow down. So the line's going to get less steep as they're slowing down. I agree, G2.
I'm nervous.
Landon, you got 2 left. Confident on either one.
E, G4.
Left my transponder back on your planet. So they turn around, head back to the planet. So here they go. They turn around, head back to the planet. Time continues to go, of course, back to the original planet. G4 is correct. So let's talk about F then being G5. Going pretty slow, so our line's not very steep. Then they really kick it in gear where it goes super steep, and then they slow it back down after he says, whoa, that's too fast. So slow, super fast, oh, we gotta slow it down. And then we continue.
I would disagree.
I did good.
All right, last page. Directions. Kira, would you read that one, please?
For 11 or the directions?
The bold up there first.
Subtracting a positive number and dividing by a number greater than 1 show decay rather than growth.
Okay, so that means it's going to be going down. That's all that means. Continue. 11.
Me? Oh. For each story, fill in the table and use points to sketch a graph that shows decay by subtraction or decay by division.
A.
Asher jogs the 24 blocks from the school to his house every minute. He is 3 blocks closer to his house.
Is this decay by subtraction or division? Let's check it. Okay, starting off from school, you're 24 blocks from your house. After 1 minute, how many blocks are you away from your house based on what Kira read? 21. After 2 minutes?
18.
3 minutes?
15.
4 minutes?
12.
5 minutes?
9.
4. 9.
All right, just to show what that will look like on a graph, 0, 24, 1, 21,
They're going down,
2,
decreasing.
18, 15, 12, 9, and that would continue on, of course.
Mr. Milburn, what did we call that again when we did graphs when it's decreasing?
Negative slope.
Yeah.
So are we subtracting or dividing?
Subtracting.
Subtracting. Nice and steady, just the opposite of addition. Graph is going down instead of up. Question B. Devin, would you take that one, please?
The desired affects a colony of 96 mice, and their population is heavily every day. Is there divide or subtraction or division?
Okay, so you got a disease in these mice, right? Disease can really affect population of something. So these are going to cut in half every day. So if you start with 96, the mice have disease, half of them die. How many are left on day 1?
90.
Half of them are alive.
Oh, 53.
No, that'd be half of 106.
40.
30.
Half of 96 is what I'm looking for.
45.
You might have to actually take a number and divide it by 2 on your paper if you can't tell me what half of it is.
There's calculator.
You shouldn't need to, just to divide it by 2.
8 in it because
Landon, you don't need that.
8.
43, but that
48.
48.
I was close.
Half of that.
I said 45.
28, 4.
Half of that.
12.
12.
Half of that.
6.
3.
3.
All right, so after 5 days, you're down to 3 mice. That is not a nice, easy decrease. So day 0, 96. Day 1, 48. 2, 24. 3, 12. 4, 6, 5, 3. And as we expected, it is not a nice, easy line like the last one.
Division.
That is certainly division.
We're gonna do tough stuff.
We've done enough of those, I think.
No. We have not done enough of those. Those
Go to
are
page 7. Your homework for today. You have one to do on your homework, Landon. That'll be fine.
I don't know how to do these.
For the questions up top, draw the shapes just like we did in their example. Make sure you answer if it's addition or multiplication. Question B, that's the same thing we got done doing. What are you adding or what are you multiplying? Question C and D, you come up with your own situation. That will go up by addition. And then do the same for multiplication as well. So there are only 5 questions there,
Mr. Milburn.
and you have plenty of time to work. And that will be due, Landon, tomorrow.